All right, guys, so remember, implicit differentiation. So what is the difference? So implicit. So everything before this lesson has been explicit. X's and Y's stay separate. I solve for Y. Okay? The reason this one is different is because we see things where X and Y are living in the same world, they're playing in the same playground. Where we can't solve, I can't solve this guy for Y. I can solve it for X, but I can't solve it for Y. And then I showed you a couple examples. Explicit are lines, parabolas, things like that, right? Non-functions, things like this, okay? So that's the difference between them. Still use the same exact rules. There's no extra rules that we haven't learned. We've learned all the rules. Product rule, power rule, quotient rule, chain rule. That's it. Those are all the rules you're going to use for derivatives. Okay? Okay, so I highlighted some things here. Equations, tangent lines. So when you see those words, equations, or tangent lines especially, what are we definitely going to need to do?
Find the derivative.
Derivative, right? Find dy over dx, or y prime, whatever you want to. So we definitely need to find a derivative, right? Equations of lines. Y minus y1 equals slope x minus x1, right? That's the guy we need to fill out. So I'm going to put that over here. But they also said equations, so there might be more than one. Okay, we'll get to that when we get to that. But for right now, and I already know my x, right? It says x equals 1. Boom. Okay? So the first thing is first, I need to find the derivative of this guy here. Okay? So let me rewrite it. Negative x y squared plus 5x equals 1.
You do the quotient rule for the negative x, y squared.
Not quotient, you're close.
I mean the product.
Product rule, yeah, because it's multiplication, right? That's multiplication. So to do the derivative of this first term, I'm going to need the product rule. And then I'm going to need to find the derivative of the next term. That's just the power rule, right? It's going to be 5. And then the derivative of the last term on the other side of the equal sign, 0. Okay? So the first thing is the yellow. So product rule. So the product rule says the first times the derivative of the second.
2y times y prime.
There you go. 2y, and then it needs a tag, right? Y prime or dy dx. Either one is okay. Because I found the derivative of y. Anytime you find the derivative of something other than x, other than the independent variable, you got to use a tag. Okay, plus, now the opposite. The derivative of the first, negative 1 times y squared. I don't need a tag there because I didn't find derivative of y. I found derivative of x. Okay, that's the derivative of the yellow. Okay. Now the derivative of the green,
5.
just 5. And then derivative of the pink is 0. Okay, so now I need to get dy dx by itself. Okay, so let me clean this up a little bit. I have negative x, or actually no, let me move the 2 in front. So negative 2xy, and then there's a tag here, right? This guy's got a dy dx. And this is, instead of plus a negative, I'm just going to do negative y squared plus 5 equals 0. So this guy plus y squared. Y squared doesn't have a dy dx, and neither does negative 5. So I'm going to subtract, add y squared since it was negative, and subtract 5 since it was positive. Negative 2xy dy over dx equals y squared minus 5. Okay, how do I get dy dx by itself? Divide by what I don't want, right? I want to keep dy dx on that side, so divide by what I don't want to keep. Negative 2xy.
Would the y's cancel out or no?
No, because the top is a binomial. The bottom is okay because it's a monomial. It's got no pluses or minuses inside, but that's where I stopped before. But that's not, they weren't just saying find the derivative. They were saying find the equation of the tangent line. Okay? So now I have to, what am I going to do with 1? Plug it in. Plug it in everywhere there's an x. So I'm going to go dy over dx when x equals 1. So everywhere there's an x, I'm going to plug in a 1. There's only an x on the bottom. Okay, so I'm going to rewrite it. Okay. So that equals y squared minus 5 over negative 2y. Okay. Let's see. Okay, so now what I got to do is I got to figure out what y value goes in there. Give me 1 second. Let me. What the heck did I do? Sorry. I know what I got to do. Okay, so I know x is 1, right? We took x is 1. But we need y, don't we? We also need y.
Plug it into the first original value?
Plug it into the original. So that's what we're going to need second. That's what we're also going to need. Because this has x and y's, we're going to need... so how do we find y? Plug it into the original. So plug in x equals 1 to the original. So negative 1 times y squared plus 5 times 1 equals 1. So negative y squared plus 5 equals 1. Subtract 5 from both sides. Negative y squared equals negative 4. I don't want negative y squared. I want positive y. So I'm going to divide by negative 1. I don't want y squared. I want y. So what is y going to be equal to?
2.
It's got actually 2 answers.
Positive 2 and negative.
There you go, plus and minus. Why? Because anytime we take a square root, could be positive, could be negative. So there's actually 2 points. There is 1, 2, and 1, negative 2. Those are 2 points on the graph.
have to put those in.
So we're going to have to plug in both to our derivative. So we're going to plug in positive 2 into our derivative, which is down here. And negative 2 into our derivative for y. So we're actually, remember at the beginning it said equations. That's why we have 2 equations, because we're going to get 2 derivatives. One of them is going to be for positive 2, and one of them is going to be for negative 2. So now I got to plug in positive 2 and negative 2 into my derivative. Okay, so first positive 2, then negative 2. So 2 squared is 4 minus 5, 4 minus 5, and then negative 4 on the bottom. So I get negative 1 over negative 4, which is 1/4. I shouldn't write it right there. Positive 1/4. The other guy is going to be 4 minus 5 over positive 4.
Negative 1/4.
So that'll be negative 1/4. Those are my 2 slopes. This guy is a good example of a FRQ waiting to happen. I've seen FRQs where they ask you this. Not so much multiple choice. These are mostly, especially when they ask you for equations of tangent lines, that's a FRQ. You guys had one like that on last week or the other day. Okay, so that guy was my slope, was my derivative when x is 1 and y is either 2 or negative 2. Okay? Okay. All right, let's try the next one. Next one's very similar. The only difference is they actually give you the points. They don't say, here's x, what's y? They give you the point. I have x, I have y. And I don't need an equation. Doesn't say anywhere about an equation there. It just says, what's the derivative at that point? What's the derivative at 2, negative 1? Well, what do I got to do to find the derivative? What do I got to do first? Find the derivative, yeah. Find the derivative, right? Because the derivative is just the slope. Okay, so let's find the derivative. The derivative of y cubed is 3y squared. But it needs a tag because it's derivative of y. dy over dx. The derivative of 2x is positive 2. Doesn't need a tag because it's just derivative of x. The derivative of 2x, or sorry, x squared is 2x. The derivative of negative 2 is 0. And the derivative of y squared is 2y, and this one needs a tag. dy over dx. Okay. So you have an option here. You can go in one of 2 ways. You can isolate dy dx now, or you can do it later. It's up to you. Since we're used to doing it first, I'm going to do it a little differently. The reason I'm going to isolate dy dx later is because they've given me a point. x is 2, y is negative 1. So they want to know the derivative at that point. So after I found the derivative, plug it in. So everywhere there's a y, I'm going to plug in a negative 1. Everywhere there's an x, I'm going to plug in a 2. Okay. So there was a y, 3y squared, so I'm going to plug in negative 1. 2x, plug in a 2. Plus 2y, plug in a negative 1. So I get negative 3 times dy dx, or y prime, plus 2 equals 4 plus negative 2 dy dx.
Does the square root not?
Sorry, did I miss
Yeah, the
something?
square by the 3 negative 1.
Oh, yeah, yeah. Sorry, yeah, you're right. No, for sure.
So it'll be positive.
So it's going to be positive 3, yeah. Thank you. Yeah, that definitely matters. Now we can isolate dy dx. Everything with a dy dx get on one side, everything else get on the other. So this guy and this guy have a dy dx. Positive 2 and positive 4 do not have a dy dx. So it doesn't matter which side you get them on. I'll subtract 3 dy dx. And then subtract 4 from both sides. Probably should use different colors. So what happens there is these guys go away, these guys go away. So now I have negative 2 equals negative 2 dy dx minus 3 dy dx. Are those like terms? Yeah, they both have the same tag, dy dx, right? So I can actually add or subtract them. So you're going to get negative 5 dy dx. Negative 5 dy dx. Negative 2 on that side. What's the last step? Divide by negative 5. Dy dx equals positive 2/5 because a negative divided by a negative makes a positive. Done. That is the slope of the tangent line at that point. Okay. Mm-hmm. Yeah.
I have a question.
Yep.
About
What's it?
notation from the previous problem.
Let me go back. Yep.
When you plugged in x equals 1.
Yeah. The derivative is 2x plus x dy dx plus y plus 2y dy dx. I don't have any points to plug in, so I got to solve for dy dx. So anything without a dy dx, I'm going to do the opposite to move it to the other side. Factor out a dy dx. Divide by what I don't want to keep on this side.
The exact opposite.
Yeah, so this time the x and the y's are stuck together, so I'm glad that you're looking for things like that, but I guess it doesn't work this time.
Oh no, the same, like it's the exact opposite on the top and the bottom.
Oh, yeah. That too. Okay, so there's the derivative. What the heck do I do with the derivative?
Set the top equal to 0.
Set the top equal to 0 because
That's the
that's exactly, that's what I want. That's all I care about is the top because that's what's going to make the fraction 0. So this one's a little tricky because it's got both x and y's. I can solve for x, I can solve for y. So if you solve for y, you're going to get negative 2x equals y. So that's technically what y is. What did we do after we found y the last time? Plugged it into the original, right? That's what you're going to do. You're going to plug it back into the original. So everywhere there's a y, I'm going to put a little parentheses. Oops, not x. So it's not a value. It is a value, but it's got a x with it. It's okay. So negative 2x, negative 2x. So we get x squared. If I multiply these two guys, I get negative 2x squared. If I square this, I get 4x squared.
And you can factor an x with that. Mm-hmm.
Well, before that, I could, yeah, before that I can combine some like terms, right? They're all x squareds.
Maybe 3x squared?
So it would be 3x squared, right? 3x squared equals 6. Divide by 3. 2, right?
So square root of 3 equals x.
So you're going to get two answers, positive and negative square root of 2. So we're going to get positive square root of 2, negative square root of 2. We just got to find y now. How do we find y? Yeah, plug it in right there. So it's going to be negative 2 times whatever x is. So negative 2 square root 2, positive 2 square root 2. Because it's just negative 2 times whatever x is. There it is. Okay, one more thing, last thing. We're not going to do both of them because they're both second derivative problems. I just got to show you how to find the second derivative and then we're done. Okay? On Monday, I'm not going to be here on campus on Monday, so I'm going to leave the practice for you, and then I'll be back on Tuesday. So if you guys have questions, I'll answer those on Tuesday. So let's just do example, the next one, and we'll be done. We won't do 11. It's the same type of problem, second derivative. All we got to do left is find the second derivative. In order to find the second derivative, you got to find the first derivative. So 2y dy dx (2x plus 2). Solve for dy dx. Oops, what am I doing? dy over dx equals 2x plus 2 over 2, y. And they all three terms have a 2, so you can divide them to make x plus 1 equals y. That's the first derivative. If they just wanted the first derivative, you'd be done. We got to find the second derivative. So what are we going to do to find the second derivative? Quotient rule. We got to use the quotient rule. So d squared y over dx squared, that's just the notation for second derivative. We're going to need the quotient rule. Low squared. Low times the derivative of the high, 1. High times the derivative of the low, dy over dx. Okay, so essentially you have y minus
X times dy dx plus dy dx.
So yeah, I'm not going to distribute this for a reason, watch it, and I'll tell you in a second, but this is essentially what you have. Then you get stuck. You're like, oh, I'll solve for dy dx. That's not what you're trying to find. You're trying to find this guy. So you can't solve for dy dx.
So you would have to plug in the first equation.
So what you got to do is, you got to plug in that guy in for dy dx. So we're going to plug in this guy in there. That's the only difference between finding the first derivative and finding the second derivative. They won't ever ask you to find anything bigger than the second derivative for these guys. Second derivative is as far as they'll go. So you got y minus, and then you got x plus 1. Oops, brackets. Times. Now instead of dy dx, you're going to plug in what the derivative actually is. X plus 1 over y. Simplify. Simplify as far as you can. So that guy I'm going to put over 1. It's going to be y minus x plus 1 squared. Oops, why am I do that so high? Over y.
What about the square part for the y?
Oh, yep, you're right. Sorry.
Would you move the y down? Or?
No, see, here's the thing. If this was a free response question, move on. The only time I wouldn't say move on is if it's a multiple choice question. Sometimes these pop up on multiple choice. You guys saw it. There was one on your test that a lot of you did, but you couldn't make, you're like, I can't get this to equal this. I don't know why. So I'm going to show you real quick, since we got about 10 minutes, I'm going to show you how to make them the same. It's not hard, but you just got to use some of your math skills to do it. Okay. So what I'm going to do is I'm going to make this an over 1. I need a common denominator. It's going to be y. So you get y squared over y minus x plus 1 squared over y squared. Now I can combine the top. Y squared minus x plus 1 squared over y squared. Keep, change, flip. Keep the bottom, multiply, change it to multiplication. Reciprocal of this guy.
Equals y to the 3?
So the bottom would be y to the 3rd. The top would be y squared minus... you're done. Again, I'm okay with this answer. If it's a free response and you put that answer, 100%, I'd give you 100%. But as you guys have seen, not all the time. If it's multiple choice, this is going to be the one they have up there. It won't be the first arrow, it'll be the second arrow. Okay, so you guys got to know how to use common. This didn't have anything to do. Here's the thing. This right here has nothing to do with calculus. That's not calculus. That's math 1, math 2, and math 3. But sometimes that's what we struggle with the most. Not sometimes, it's probably all the time. You guys are good with the calculus because there's not much to do. Find derivatives, find limits. That's pretty much all we've done. You guys can do that really well. But sometimes it's those skills that you learned back in math 1 and math 2 and math 3 that slow you down. Okay? Okay.